In this video, I'm going to show you how to build a search feature for your Swift mobile application that uses Parse as its cloud backend. And the way it's going to work is this. In my browser window, I have Parse application opened, and this Parse application has a class or a table called friends, and this class has 3 records in it. Each record is a record of my friend. And each friend has a first name and last name, and our mobile application will search against this table for one of the names. So for example, my search keyword will be Bill, and I can tap on search and it will find Bill, and the search result will contain first name and last name. Or I can type, for example, family name Bond, and it will find Bill Bond as well. So now let me search for partial family names. So for example, I will type family name partially only, and hit tap on search, and I have 2 search results now. My Sergei Kargapolov and Olga Kargapolova, 2 records were found. So the search will be against multiple fields. So you can search for more than 2 fields. You can, if your class has, for example, other columns you need to search for, you can do that. Okay, so yes, and user interface is very simple, and we have a clear text field button here, and we have cancel button, and we have refresh button, which will clear the search field and clear the text, table view, for us to begin a clear search again. Okay, so let's start and implement this search feature. One requirement you need to have for this mobile application is that you need to have Parse application created. I have, it's called My App, and it has one class, friends, and you should have Parse SDK downloaded and installed in your project. I have it here. So I have an empty project open. It doesn't have anything but view controller. So I'll just grab this Parse libraries, and I will add them into a group called Parse libraries, something like this. Those are libraries required for Parse SDK to work. Okay, so let's go ahead. We have view controller, and I will select navigation item, and I will call it search friends. And now I need to have a table view, so I will search in my objects library. I will look for table, and I'll drag and drop table view. And this table view will have one prototype cell. So I will select table view, and on the right side panel here, I will look for prototype cells, and I will increase this value to 1. I need 1 cell, and now I will select this cell, and I will give it an identifier. This is very important. Let's give it an identifier, my cell, and let's remember that we will use this identifier when we dequeue this cell in our source code. Okay, so a table view is created. Now we need to look for a search bar. So I'll grab the search bar, and I will drop it right above the cell here. If you could not, if you could not drop it here, if you accidentally drop it below the cell, you can open document outline by tapping this little button here at the bottom. And then you can reposition the search bar properly. So it should be right above the cell. And now we need to look for a button. And it shouldn't be just a button, it should be bar button item. So we'll select this bar button item, drag and drop it at the top right corner here. So that will be our refresh button. Let's select this button, and on the right side panel here, under with this attributes inspector, we need to look for let's choose from the identifier, let's look for refresh. Here it is, refresh. Okay, so our user interface is created, and next we need to while we're here, let's connect some delegates. So there's one delegate that we need to create a connection with, and the way I connect delegate is like I selected the search bar and I hold control button on my keyboard, drag and drop it here to my view controller, this yellow button, the first one, and I need to create an outlet for it, so the delegate should be selected. Okay, so one for search bar, and now two for table view, one for data source, and one for delegates if you want to handle interactions with table cells. Okay, so let's connect this two. Let's create two outlets. I will connect delegate as well. So now two of them are connected. Let's check. Yes, data source and delegate are connected. And let's select the view controller and open it in Assistant Editor. So these two circles here, Assistant Editor. Okay. There are a couple of more outlets we need to create, and one for table view. Let's select the table view, hold control button, click, drag, and drop it to our source code. And I will call this outlet my table, very simple. And one for search bar. Select search bar, hold control button, click, drag, and drop it here. And I will call it my search bar. Okay, now we are ready. So first of all, for table view to load some data, this data will come from Parse Cloud. So we will need to import Parse. Because Parse SDK is already installed in our project, it should just work. So next, there are a couple of, because we're using table view, our view controller need to conform to a couple of protocols. One for UI table view data source, UI table view data source, and one for UI table view delegate. Now, when I hold control button on my keyboard and click on, command button on my keyboard and click on table view data source, I will be able to see the list of functions that protocol defines. And there are a couple of them that are not optional, like these three are optional and the first two are required. I will need to implement these two functions. So I will copy them to my source code. Somewhere below here, let's delete this comment. Yeah, I'll paste them here, delete this comment as well, and add body for each of the functions. So now first function will return number of rows in our table view, and it will depend on the number of on the search result, how many records were found in our database. And the other one will need to return table view cell for each record, and we can implement both of these functions right now. So let's create a new variable that will be search results, and this variable will be an array of strings, and our table view number of rows and section will return number of rows in this array, or number of items in this array. Okay, and the cell for row at index path will return a table view cell, and this table cell will need to be dequeued. So let's declare a new variable. For example, that we will create a variable called my cell, and we will dequeue this variable from a table view variable here. dequeue reusable cell with identifier for index path, this one. And our identifier is called my cell, and the index path we can take from here. Okay, and why is it called my cell? This is because we have assigned an identifier for our cell when we were creating it. So if I select the cell in my table view and then open right side panel, attributes inspector, this is the identifier I'm using to dequeue this cell. So it's very important. We don't want to make typo here, so we can actually copy it and paste it here. So now when this cell is dequeued, we can cast it to a UI table view cell. I mean, we can return it to our table view. But when the cell is returned, it will be absolutely empty. So we will need to set a value for the table cell, and this value we will read from search results. So each cell, even when it doesn't have any labels on top, it has a text label property, so I can reference that. My cell text label, and then text label has text, and we can assign this text a value from our search result. Search results index path row. So for first row, for the first row will have index of 0, so it will pick up an array item with an index 0, and it will assign the value of that item to a label here. Okay, so and this is it for this cell. Our cell will contain whatever parse will return us. We will just set it as a label to our table view cell. Okay, and now we can implement couple of functions which are delegates from the search bar. So if I scroll up here, I can make my view controller to conform to another delegate, which is UISearchBar delegate. Search bar delegate, and if I do just the same thing, like if I hold command button on my keyboard, click on it, I will be able to see functions that this protocol defines, and there are two that we are looking for. One of them is called search bar search button clicked, and the other one is search bar cancel button clicked. So let me copy these three. I will delete one that I do not need. So I'll scroll down here, just paste it somewhere here. Three functions. I do not need the one in the middle. Don't need this comment, and don't need the optional. Okay, and the same thing for the second function. Don't need these comments. Okay, so the first function will be called when a search bar search button tapped, and this is when we will send a query to our parse. And the other one is when the cancel button is tapped, and this is when we want to clear a search result, for example, and dismiss our keyboard. So let's implement this function first because it's very simple. So I will use my search bar variable here. So when cancel button is tapped, first I want to dismiss the keyboard, and the way we dismiss keyboard is by calling resign first responder. And the second one, I want to set the text in this search bar to an empty string. So that will clear the text field and dismiss the keyboard. Okay, so let's go ahead and implement search bar button tapped. Well, when this button is tapped, we will do the same thing. We will first resign first responder. We will make our keyword disappear, and then we will start creating parse queries. I have a little code ready so that it doesn't take me much time to type it, so I'll simply copy it and walk you through very quickly. So we are going to create a new object, a special type parse object, which is called pf query, and this object will accept parameter of the class name which we are going to search in. So if I open my browser, my parse class name is called friends. So the name of this table or a class goes to our query here. So we are querying class friends for the key first name, and that key we want to contain. We use contains string, and we use our search bar, which the parameter comes here. When this function is called, it will make search bar available to you with the search bar parameter. We can read text. So we create first query, and then we create another query. And the reason we use two queries is because we want to search for two keys. We want to check first name and last name. So these are called, and when we use two queries together, these are called compound queries in parse. And then we create a third query with the two subqueries. So this will be one subquery, and this will be another subquery. And when we add them as an array here, so first query name and then the second query, and that will execute, that will prepare our query for the execution. And now we can use another parse function, which is called find objects in background with block. So this function will actually execute this query, and it will execute it in background, so your main thread and application will not be blocked, and application will not freeze. And once request completes, this completion handler will trigger, and it will make two objects available to you: results, which will contain the returned results from parse, and an error object if an error took place, like request timed out, for example, our internet connection was not available. So this object will contain a description of that error. So first of all, we can check, for example, if error is not nil, then something went wrong, and we can display that error message. And we can use localized description of an error message. And I also have a little piece of code ready for you to display an alert controller. So if error took place, we can display a very simple alert message. Like we will create alert controller with a message which will be a localized description from our error. That will be a friendly description that we can display to our user. And then once we display this alert, we do not want to continue, we'll simply return, and user can read alert message and tap on OK button. But if everything went well, if we have a results object, then we can display these objects in our table view. And I also have a little piece of code prepared, so I don't have to type too much. I'll paste it here and I'll walk you through. So what we do here, we use iflat, basically saying that if our results contains data, we will assign this data to objects, and that will be an array of parse objects. And then we will loop through these objects, and for each object, we will read key first name and last name. Remember, those objects are parse objects, and that's why we can access first name and last name from the search result. And we will, using first name and last name, we will put them together into a full name. And then we will add this value to our search results array, which we declared at the top here, and which we use to return the number of cells that our table view should contain, and we use it to populate the label of our text field. So here we store this search results, but before before populating the search results array, we will remove all keys from it first, because the next time when I run this query, my search result will be appended even more values. So it will contain results from the previous query. So before running this for loop, before populating my search results, I want to clean it. I want to remove all the keys from it, all the values from it. Okay, and once I done that, because this query runs in background, and if I want to communicate back to my UI, I need to dispatch a new asynchronous task on the main queue. And what that task will do, it will simply reload our table view. Let's quickly look up. It's called my table. So I will use self my table reload data, and I will use a resign first responder on search bar to dismiss keyword. So when the table view is reloaded, this function will be called first. So the number of rows will return the number of items for that our search result has. And the next function which will be called is this self-forward index path, and then for each cell it will read the value. So basically this is it, and it should work. Let's create one more connection action for our refresh button here, because we did not do that. So I'll create hold control button, click, drag and drop here, and that will be connection type action, and I will call it refresh button tapped. Okay, and basically this button will do very similar. It will resign first responder. It will actually clear the text here. It will then clear the search results, remove all case false, keep capacity false, and then it will reload my table reload data, so that the table is reloaded with, and it's empty, it's cleared out. Okay, so let's run this application and see if it works. I hope we did not forget anything. So let's run it. Okay, search friends. If I tap on search button, nothing to clear yet, so I will type first keyword, hit search, and it works. It found one friend. So if I clear that and I tap partially family name of another friend, tap on search, I have two, and now I can tap on refresh button to clear the search results. And before I complete this video, let me show you how to make this search feature case insensitive. And what do I mean by that? For example, now if I search for a friend using their first name, and I tap on search, the search result is successful because the search word and the value stored in a class is an exact match. The first character of my search word is a capital letter, and the first character in the first name stored in our database or parse class is also capital letter. So the values are exact match, and that's why the search result is successful. But if I type first name all lowercase word, the first character of the search word is lowercase, and the first character of the value stored in our parse class is a capital case, uppercase letter. So the search result will not be successful because values do not match. That's called case sensitive. So let's make our search case insensitive so that users can type lowercase search words and still be able to find values in our parse class. And we will scroll down a little bit to our function called search bar, search button clicked. And here, when we compose our queries, we can use a different function for, let's, for example, experiment with the last name. So I'll copy the last name query, and I will look for where key. And here we have different options, where key is equal to, or where key is greater than, less than, matches query. So we want to use regular expressions here. So we need to select where key matches regex, regular expression. And I'll select this function, and I'll provide the class name, and that will be last name matches regular expression. And here I need to provide a regular expression that will match the search word and the value in the parse class, and the comparison will be case insensitive. And the regular expression is actually very simple. It looks like this, question mark I. And then I will append, I will add here our search word. So it's search bar text. And that should work. So if I save this now and run again, let me search for the family name or the last name and use all lowercase characters. So now if I search, for example, with a capital case for Kargapolov and search, the parse returns me 2 records that it matched. But if I search for a lowercase family name, it still finds it. So let me type something that does not exist. It doesn't find anything. And again, the family name with the lowercase, uppercase finds, and lowercase still works. Okay, so I guess this will complete this video, and I hope it is useful and helpful to you.